Alrighty, here we go. We are cruising along. We're proportions masters now, and what we're going to do is apply proportions into some more realistic type of situations, and today's going to be indirect measurement. So at the top of your notes, make sure you've got Chapter 5, Section 7, Indirect Measurement, and we'll zoom along to today's learning target. Today, you can, or I can, what you're going to do are find measurements. Okay, so we're going to be able to utilize finding measurements of things, but we're going to do it indirectly by applying proportions of similar objects. Okay, now while you're writing all that down, just think about this. There are times when it's just not feasible, excuse me, to grab a tape measure, a ruler, a meter stick, whatever, to measure stuff. But if we're trying to figure out how tall a tree is, really, you want to be the one to climb with the tape measure? It's not always practical. So there are ways we can use math to make our job so much easier. And this is one way we do it. Okay. And it's all about proportions and similar objects. So lots of pictures here and things today. And we have to do some kind of turning around. I'm going to make you do some things that you may not need to, but because of the way my brain works, we got to do it kind of the slow, old-fashioned way. Okay, so we got to talk about what indirect measurement means, or what it actually is here. All right. So we've said this is our goal today. We're going to find measurements of things, measuring things indirectly. So what does that mean? Well, what we're going to do is use proportions and similar objects. And in most cases, I could write objects, but in all honesty, almost all the time, it's a triangle. Okay. And similar triangles to I can't even spell, to find a measurement of something. Okay. To find a measurement. And these would typically be times where it's something that's really difficult to measure. Okay. The height of a flagpole, the height of a monument, the height of a tree. Those are most of the examples that we'll run into. The distance across something where the terrain is very rugged. These are all ways we can do it mathematically without having to get all dirty and hands-on. Okay. So here we go. Let's say we've got these two triangles, and I am going to tell you, yes, these two guys are similar. And this is that symbol that we use called tilde, and it looks like a lazy S on its side. Okay, and that means that the corresponding angles are exactly congruent to each other, and the corresponding sides are proportional to each other. All right, so here's my so-called disability. I can't make sure I match things up unless I turn things in the right way, okay, or in the way that they are in the same orientation. And what I mean is that, okay, I've got this triangle. I'm going to leave this one the same. This was 5 1/10 meters, and this side was 8.3 meters. But I've got to take this triangle and I've got to turn it this way, because I can't turn things in my head. It's some sort of Lori problem here. I can't do it. So, but if I do this, then I have become a rock star and I can set up my proportion. Okay. It is totally up to you which way you feel more comfortable in setting up your proportion. There are about 8 different ways you can do this. I'm happy with any way as long as you're consistent. Okay. So one option when you set up your proportion is to go this way. You could say the small side of this triangle, which is 5.1, is to the big side of the same triangle. Okay. So now I'm thinking small side to the big side. Okay, that means I have to, in this triangle, go small side to the big side, which means I'm matching up 17 to x. Okay, you can do it that way. Or, okay, and you don't have to write both of these options down, but I want you to realize that there's 2 ways to, or 2, a bunch of ways to set it up, and they both work the same. Or if you'd rather say, hey, the little side on this triangle matches up with the little side on this one. So you could say 5.1 is to 17 as big side, 8.3 is to the other triangle's big side, to x. Regardless, your cross products are exactly the same. 5.1 always multiplies the x. And the 8.3 always multiplies with the 17. Okay? All right, so now grab your calculator, because even I am right now, there's no way I want to do this math in my head. So I got to find my calculator here in this pig pile on my desk. And we're going to take 8.3 times 17. Now in my head, I'm thinking, oh, that's over 100, probably, I don't know, 150, 160, something like that. Oh, around 140. Okay. And then divide by 5 and 1/10. Okay. And you get an answer that looks like 27.6 repeating. Okay. If you have it set up as decimals on your calculator. That's the same as 2/3, by the way. You can use, if that's one of those common decimals you should have ingrained in your memory. Your calculator, the scientific TI-30 multi-view, does it for you as well. So you decide which way you want to write it, but don't round it. If you can write it exact unless the instructions tell you to round it. So this missing side, which is in meters, since meters and the metric system is always base 10 in decimals, I think I'm going to leave my answer as decimals. And we're going to say 27.6 repeating meters. Okay. Boom. Okay. Now, the reason I had you review that is because today's all about proportions, and you got to come up with 2 similar objects. And most of the time, they're triangles. All right. So let's take a look at this next example. A 30-foot building. Okay, nice. It's labeled here for you. Okay, casts a shadow that's 75 feet long. 75 feet long. Okay, now think. Stop for a second. The shadow is way bigger than the object. Okay, the building is casting a long shadow. That tells you that the sun is probably a little lower in the sky. It's not like you need to know this, but just think a little bit about what's going on. Okay, so the shadows are longer than the actual height of the object. Now I've got a tree here, and I can see that the shadow is 35 feet long. How tall is the tree? Okay, so I'm looking for how tall the tree is, and you need to pick a variable to represent that. Me personally, I like to be Captain Obvious and call that T for tree. Here we go. You can set up your proportion any way you want. You might want to go building to shadow as tree is to shadow. Or maybe you want to say the building 30 feet is to the tree as this shadow is to this shadow. It doesn't matter. You do it how you want. Okay? Because this is like a big triangle and this is like a smaller, similar triangle. When these shadow things occur, they are indeed similar. So you can make that assumption. I'm going to say 30 feet tall, 75-foot shadow. Tree tall, 35-foot shadow. Boom, you've got your proportion. Now, even when you can see what the answer is, I need to train you in the method of showing the algebra, meaning I want you to show me that this cross product equals this cross product. Okay, don't shortcut this part. 30 times 35 equals 75 times the height of the tree, which I'm calling variable t. Don't just say 30 divided by 35 divided by 75. I want you to show me the work on this side as well. So you get used to this idea. This is an equation. Whatever you do to one side, do to the other side, and your variable equals whatever this is. All right? If you need to, go ahead and grab your calculator. Hey, in the olden days, let's see what we would do. I would say, well, I can take a 3 out of here. That'd give me 25. Factor that out. So I'd factor a 3 out of there, and that'd leave me 10. Then I could factor a 5 out of here and out of here, which would leave me a 2, and another 5 gives me 7. I think I get 14. Ha! Does that make sense? Let's go back and look here. I'm going to say that the tree is 14 feet tall. And we should ask ourselves, does that make sense with the information I've got here? Well, it has to be smaller than its shadow, which it is. And in fact, it's even less than half. And that, yeah, that's reasonable. That makes sense. Okay, there you go. All right, let's get in the groove and keep on going. Here's another shadow one. They love to do flagpole ones, so here we go. Flagpole, 20 feet tall. The shadow is 32 feet long. Here's a little girl. She's 5, I guess that's not so little, 5 feet tall. And how long is her shadow? I don't know. What do you want to call that? I'm going to call it S for shadow. All right, make a proportion. Cross multiply and solve. Show the algebra. Label your answer. Here we go. I'll do it a different way this time. I'm going to say the height of the flagpole, okay, is to the height of the girl. Okay, so I'm going to say height of the flagpole to the height of the girl has to be the shadow of the flagpole to the shadow of the girl, which I don't know. Boom, there we go. All right, if you're more comfortable saying 20 is to 32 as 5 is to S, you write yours that way. They both are going to work because your cross products are the same. 20 times S equals 5 times 32. That's 160, by the way. But then we're going to divide by 20 because 20 divided by 20 is 1. So S, which represents the shadow of the girl here, should end up giving you an answer like 8. Okay, so we will say the girl's shadow is 8 feet. Whoops. 8 feet long. Now, I always like to say, does that make sense? She's 5 feet tall. Her shadow is 8 feet. It's longer. 20 feet, 30, that's longer. Do those make a proportion? Yes. Okay, we're good. Just make sure it makes sense there. Ooh, now here's another one, but I want you to look at this picture. It's a little different, okay? Scott is 6 feet tall. Scott doesn't look 6 feet tall in this picture. He looks pretty tiny. But he casts a shadow that's 15 feet long. So Mr. Sun is up here somewhere, okay? Shining down on us. And at the same time, this tree, which I don't know how tall it is, I'm going to call that T, casts 120-foot shadow. Okay, now these are kind of overlapped images. So I just need you to get this idea. You've got this baby triangle that's 6 and 15. And then you have this giant triangle where the whole bottom is 120. And this is T. Now match up your corresponding parts. Make a proportion, cross multiply, solve, label. Boom! Here we go. I'm going to stick with person is to shadow as tree height is to shadow. This time, cross multiply and solve. 6 times 120 equals 15 times T. Here's my variable. To get it alone, I would divide both sides by 15. And now we go to town. Here we go. T equals. All right, now again, in the olden days, I didn't have a calculator handheld like this. We had to do it in by simplifying the fraction. So rather than multiplying and getting 720 divided by 15, I'd say, hey, 15 is made up of a 3 and a 5. So if I factor a 3 out first, which leaves me with a 5, I'm going to take the 3 out of the 120, so I have a number that's easier to look at. And then 5, I can keep going. 5 goes into 40 8 times. 6 times 8 is 48. Sweet. Check me on your calculator. Is that what you got? All right, so how tall is the tree? The tree is 48 feet tall. And that's good because I don't want to try and climb that tree and then hold the tape measure and so on, I'd probably fall and hurt myself. Besides, when you're climbing a tree, you can't really reach those teeny tiny tops of the branches. They're not strong enough. Let's see, does that make sense? Okay. Person is 6, shadow is 15. That's more than double 6. 6 times 6 is 12. So if I doubled this and then some. So the tree of 48, double that. That's almost 100 and then some. That makes sense. Ooh, look at this one. Oh, these diagrams. Allison wants to build a bridge across this small stream on her farm. Okay. She drew this diagram and labeled it with the measurements that she could make. And here's what she knows. She's got this measurement. This little triangle is 6 and 8. And then this one is 28. And I don't know. So this is going to be the bridge, I guess, right? Bridge. I'm going to call that B for bridge. Now, here's a situation where I get all messed up because these triangles are turned around. And in order for me to get the corresponding sides, I got to redraw this. So if you don't need to do this, more power to you. But I kind of have this disability or handicap that I can't see this. So I'm going to keep the big one and I'm going to take this baby one and I'm going to spin it around and draw it underneath like this. Okay. You have this, this, this. There's my right angle. And now the 8 goes at the bottom and the 6 is here. Okay, so 6 and the bridge match up. Those are corresponding sides. The 28 and the 8 match up. Those are corresponding sides. Now you go ahead and write your proportion however you want to set it up. Me, I see 28 and the 8. So I'm going to do that, kind of like the bottoms of the triangle. 28 is to 8, as B, my bridge, is to 6. Okie dokie. Go ahead and cross multiply and solve. 28 times 6 has to equal 8 times the length of my bridge. And then to find the length of the bridge, I'm going to divide both sides by 8. So, ready or not, here we come. Let's see. If I divide a 4 out of here, that leaves me with a 2. And a 4 out of 28 is 7. Divide by 2 again into the 6, 3. I get 21. Boop. And that seems right because this side 6 was smaller than the 8, not by much. This bridge B should be smaller than 28, and 21 is. How long will the bridge be? The bridge will be 21 feet. There we go. All right. Theo. Now, here's another one of these. It's a little wonky as far as the diagram. So we got to make sure we've got stuff situated. Theo wants to know how wide the pond in the city park is. He drew this diagram and labeled it with the measurements that he made. How wide is this pond? Okay, from here to here. That's what we're looking for. So it's the pond, huh? Well, I'm going to use letter P for pond. Okay, but this is a little weird and we kind of need to turn things around because we can't just flip this upright, this baby triangle. Okay, we've got the big one like this. This is the right angle. This is P and this is 30. And then this one, this baby triangle, we need to turn around to orient it in the same position as the one above it. Okay, so the 12 is here, 12 meters, and then when we turn it, the 9 ends up over here. The 9 is in the same position or in the corresponding part as the 30, and the 12 corresponds with the width of the pond. Now I can go to town because I'm not encumbered by my own inability to turn things in my head. So let's see. Should we do it this way this time? The pond matches up with 12. So the pond is to the 12 as 30 is to 9. We can do it that way this time. P times the 9 equals 12 times 30. Or if you'd rather say P over 30 equals 12 over 9. Okay, so you decide which one you want to write down. And then you're going to get the same cross products we'll get the same algebra. So we're all good. Divide by 9, divide by 9. P equals 12 times 30 divided by 9. In the olden days, we'd just start simplifying the fraction. Factor a 3 out. That leaves me a 3, and this would be a 4. 3 into 3 is 1. That gives me 10. Looks like I get 40. How wide is the pond? The pond is 40. We're in the metric system, meters wide. Because, everyone else on the planet uses the metric system, but not America. Don't get me started. All right, so you are now masters of indirect measurement. It's a way to be more efficient, okay? You use proportions, apply that to similar figures, just like we said in our learning target. And now I'm going to turn you loose on the workbook, page 38. Good luck, and may the force